Welcome to the lecture series of Embedded Controller. So in the last lecture, we have seen about the timer and counter, how the control registers are configured and what are the different types of timers available. So here in this video, we are going to see the interrupt flag, which is very important when the timer needs to stop. So let us move on to the lecture. So this is the interrupt flag. So it is very important in case of your timer action. So timer 0 IF in the sense interrupt flag. So this timer 0 interrupt flag is a part of interrupt control register. So for example, if I am counting, let us take for 2 bit. So 0, 0, 0, 1, 1, 0, 1, 1. So this is my 2 bit. So if you understand this, you can easily understand about 4 bit or 8 bit or 16 bit, whatever it may be. So when the timer, if I am giving 10 milliseconds delay, then automatically the control registers will configure the value and the particular value, hexadecimal value, will coded into your TCON register. So later, when I have to start the counting, once it starts counting, when it will end, when it reaches 10 milliseconds, the timer should stop. So otherwise the delay may increase. So when it stops, so for example, if it is 2 bit 0001 1011, if it reaches 11, then it needs to stop. Okay, that is the condition. So for example, just I'm start counting my 00 as 1. Now again it will add to 1. So this will be made as 01. Now this is the count 2. Now again 1 is added here. So this will be made as 1, 0. So this is your count 3. And now again adding 1. This will be your 1, 1. Now the maximum limit of 2 bit is reached. So this is the 2 bit delay. So now it is reached. So again if I am adding 1, this will be named as 0, 0. So when my 1, 1 is changed into 0, 0, at this condition, I have to stop the timer. I have to stop the timer action. So that condition is nothing but rollover. So this is nothing but rollover. When this rollover happens, the timer interrupt flag will get enabled. So enabled in the sense this bit will get 1. So that means the timer is overflowed. It is showing the time. It is showing that the timer is overflowed and the required delay is achieved. Okay. So when timer reaches its maximum value, if it is 16 bit, so maximum it is 1 1 1 1 1 1 1 1 1 1 1. So like 16 ones. If it is 8 bit, 8 ones. So this is a maximum number for 8 bit, 16 bit, 4 bit, 2 bit, etc. Okay. So if it reaches the maximum value, from the maximum value, it has to change to 0 0 0 0. Everything is 0. That condition is nothing but a rollover condition. So when all ones is converted to 0, at that time the timer interrupt flag is set. That set in the sense it becomes 1. So the timer interrupt flag is a part of interrupt control register. This particular third bit is timer interrupt flag, timer 0 interrupt flag. So if this particular bit is 0, then timer is did not flow. So until it reaches 1 1, it will be 0 condition only. For 0 0 0, it will be 0. For 0 1, it will be 0. 1 0 0. 1 1 0. When it becomes 1, when 1 1 again turns over to 0, this timer interrupt flag will be converted into 1. Okay. From 0 to it is changing to 1. Now the timer knows that the click, that is counting, should be stopped and the timer is overflowed. Okay, this is very important to stop the timer. Okay, so that is timer interrupt flag. So this is how the overflow flag works. So normally the frequency is given. So once the timer is on, the input is given with and if it is 16 bit, so two 8 bit registers are used. So when this F so goes to 0, that is all ones again reaches 0, at the time the timer interrupt flag set to 1. So that is, it is your overflow flag. This is timer 0 overflow flag. And similarly, we can configure the 16-bit programming by choosing TMR06 and TMR0L. When it reaches the rollover limits, automatically the programming stops. So the timer interrupt flag is set when FFF2 reaches from FFF to 000, which is the part of interrupt control register. So here the two registers are used. So the timer interrupt flag again should be reset after completing the action. Initially it will be made as 1 when the rollover occurs. So again, if I want to use the timer from starting newly, again this timer interrupt flag will reset to 0. So this is how the timer interrupt flag will work out for 16-bit programming as well as 8-bit programming. So these are all the steps to program timer 0. So first load the value into TCON register, and then load the register followed by TMR0 and TMRH, and wait for timer 0 interrupt flag to make it as 1, and again you have to reset. So this is the block diagram, and the formula shows how the time delay is created. So first, convert the hex values of TMR0H, TMR0L register to the decimal to get n numbers. So that is 6553066 will be, the number will be subtracted from this to get the time delay. So similarly, if time delay in the hex value, then FFF, from FFF it is subtracted and plus 1 into 0.4 seconds. So similarly, prescaler values as we have already discussed. So if I am using the prescale value, then divided by 4, again it will be divided by 64. So this is my prescale value. So further the frequency is reduced, so the time delay can be increased further. So you just to try this example, find the value for TCON. If you want to program timer 0 in 16-bit mode with prescaler of 64, use internal clock for clock source positive edge. So all the conditions are given. You just go with as in the last video we have discussed the T control register configuration. You just load all the zeros and ones there depending upon the requirement, and you can find the value that is to be loaded into a TCON register. So hope you understood.